what if we go out of quadrant 1? Okay, that's when we start being able to differentiate between regular trig, where we're just using positive values, and circle trig, where we can go into the negative values of x and y. So let's take a look here. This one here, we're still in quadrant 1. Here I have the y and x coordinates. Okay, I have 5 on the x, 22 on the y. That's going to be my slope ratio or my tan ratio. So I'm going to say tan theta equals 22 over 5. Well, to solve this, I need my arctan. I need to inverse this. So I'm going to write the inverse form. That's going to give me theta. And I just use my calculator because this is not something I can do without a calculator. I need something to translate between the angle description and the ratio description. So the ratio is 22 over 5. That's my slope. And to convert the slope into angle, I use arctan. So my angle theta works out to be 77.20 degrees. And if I look at my picture, that looks pretty good. Okay, that looks pretty accurate. Okay, so this is just the same, describing the same thing, but now with an angle. Okay, and again, I needed a calculator to be able to go between the two. Now, this is also asking for the radius. So if I want to find the radius, I can use Pythagoras. So 5 squared plus 22 squared. Okay, so it's going to be square root 509. Now, I'm not going to find the decimal value for this because that's not something I want. If I have exact values, I want to keep the exact values. And that's implied when we're dealing with circle trig. So here I have another position in quadrant 1. This time I have the radius and the vertical position to locate that coordinate. Okay, so that position of that coordinate is very important. I want to know the x length here. To do that, I need to use Pythagoras. So I'm going to do 400, so 20 squared minus 9 squared, which is 81. So I'm going to end up with 319 square root. I'm going to leave it like that. Okay, we don't want to mess around with the decimal values. We want to use exact values when possible. Once I have that position, I can use the x position over the radius to get my cosine ratio. And again, I'm going to leave it like that. I want exact values when possible. There may be some rare times where we need to convert this to decimal, but for the most part, we're just going to keep the most accurate exact values that we can. Here, the sine ratio is going to be 9 over 20. Sine goes with y, cos goes with x. Tan is my slope. Okay, so there's my slope. So everything in terms of ratios, I don't need a calculator. I can just see very clearly that the ratio parts, all the measurements, I can do all the calculations for the measurements, so I don't need a calculator to do anything when I'm just dealing with ratio, or length. Where I need to use my calculators now is, I want to convert this ratio measurement of this angle, okay, to the degree measurement of that angle. So I'm going to use an inverse operation. So I can use inverse cos, inverse sine, inverse tan. Doesn't really matter. I'm going to use my sine. So I'm going to say that the inverse sine of 9 over 20, the ratio is going to give me the output of the angle. My angle works out to be, so 9 over 20 inverse sine is going to give me, let's see here. I think I've got something a little bit messed up here. Okay, so I'm going to try that again. 9 divided by 20. And then I want my inverse sine Okay, so I get 26.74 degrees. Okay, so this sine ratio of 9/20 describes the shape of that triangle. The angle 26.74 also describes the shape of the triangle in degrees now, okay, with the angle. All right, so here I've been given a cosine ratio, and I need to figure out the other trig parts, and I need to find out all those different parts here. Okay, so I've been given the cosine ratio of 0.15. So cosine ratio equals 0.150, and I know that's going to be the x over my radius. Well, if that's the case, then I can probably figure out my radius. Okay, so my radius is going to be equal to 10 over 0.15. Okay, that's not going to be a really nice number, but 10 over 0.15. Okay, it's going to give me 66.6 repeating. Okay, so I'm just going to keep that as fraction. I'm going to make that, what's that going to be? 15 over 100. So it's going to be 200 over 3. Okay, so I'm going to keep that as exact value. My sine ratio then, so this is going to be 200 equal to 200 over 3. I need to use Pythagoras to solve for the y coordinate. So I'm going to say y squared is equal to the square root of 200 over 3 squared minus 10 squared. Okay, so y squared works out to be, that's going to be 40,000 over 9 minus 100, so I'm going to make that 900 over 9. So y squared is equal to, let's see, is going to be equal to 33,910 over 9, and we'll square root both sides of that to get that expression. And I'm just going to simplify that to factor out the 10. So it's going to be 10 over 3 square root 391. Okay, so there's my y coordinate. Okay, so I'm going to write some of this down here. So y is equal to 10 over 3 square root 391. The sine ratio then works out to be y over the hypotenuse. So I'm going to have to simplify this, but over 3 over 200 over 3. Okay, so that's going to simplify to the 3's cancel out, and the simplified form of this is going to end up being root 391 over, looks like 20. Okay, so there's the sine ratio. My tan ratio works out to be the y over the x, so it's going to be this y coordinate divided by 10, so it's going to be 391 over 3 when you simplify it. Okay, the radius we worked out as 200 over 3. It's a little bit messy because of the fractions when we're trying to keep exact values. Now, we could kind of cheat and do decimals, but really we want to try to keep exact values when possible. So the last part of this is we need to then convert this into an angle. So I'm going to use a tan. So I'm going to use arctan because that looks like the easiest number to work with. So I'm going to take my ratio and convert it to an angle using the arctan function. So I'm going to do square root 391 divided by 3, and then we're going to apply the arctan to it, and we're going to end up with the angle theta works out to be 81.37 degrees. And that looks about correct based on this picture. Okay, now this picture is not quite accurate, but it's relative. It's not too far off.